So today we're continuing to solve inequalities. So what we did yesterday was we solved with inequalities, meaning things with graders and lesses, not equal signs, but the other signs. We were doing that with adding and subtracting. With adding and subtracting yesterday, what we did was we did the opposite, and we never changed anything about the less or greater signs. Those always stayed the same. And I told you it would yesterday only, and that today things would be different. Today, when we solve inequalities, if we're doing multiplying and dividing for our opposites, about half the time, the sign is going to change. The greater might change to a less, or a less might change to a greater. So here's the rule on that. We're going to turn that greater or less sign to go the other way, whichever way it's going. If you ever multiply or divide by a negative, the negative has to be in the problem with the variable. So some of these problems, if you scan around the board, they all have negatives in them somewhere. Sometimes the negative is with the variable, and we care about that. That's going to make us turn the sign. Other times the negative is not with the variable, in which case we just don't care. That's not going to have anything to do with us turning the sign. Half the time the problems, the signs are going to stay the way they are. The half that we turn is when the negative is with the variable. So here we go. This problem has actually no negatives in it. So I told a small fib a second ago when I said they all had negatives there. They don't. This first one doesn't. Most of the rest of them do. So this, clearly, the sign just stays the same. Okay, we're going to do an opposite to get the x by itself. If there's no negatives in view, the sign is absolutely going to stay the same. Since 8's multiplying, you would divide by 8. X is alone. If you divide by 8, we would turn out a 4. And we need, like yesterday, all of that to be in the answer. We need the x, we need the sign, we need the number. It's not enough to have the number. We need the x, the symbol, and the number. It's very different if we're more than 4 versus less than 4. More than 4, we might have a million. Less than 4, you might have negative some incredible amount. We need to keep track whether we're more or less than the number. So this is vital to the operation. So for this one, we're looking to, again, divide. Okay, these first bunch of problems, they're all multiplying on the board. We're all going to divide. This one, there is a negative in it, and the question becomes, is the negative in a position that it matters? The negative only matters if it's with the variable. So this negative does not matter. This sign is going to stay a greater. And by matter, I just mean matter in terms of switching the sign or not. Okay, so this negative does not cause the sign to switch. So we're still a greater. We need to get the x alone, so our answer has an x, a greater or less, and a number. To figure out our number, since that's multiplying 4, we just have to divide by 4. If we divide by 4, we get negative 5 out of that. When we go to do the next one, we got a ton of negatives. Okay, this one doesn't matter for turning the sign, but this one does. So for the first time on our board today, the less turns into a greater, because the negative that's multiplying causes that to happen. When we go to get this x alone, we'd have to divide by negative 5, and remember our divide rules. When we divide a negative by a negative, that's a positive. 30 dividing 5 is 6, and that's what we're at. For this, we'll want to get the x alone, and then the question is turn or no turn. So ask yourself that question at home, and the answer is turn. We are going to turn the sign, because there's a negative with the variable. Anytime there's a negative with the variable, turn the sign. When we divide a positive by a negative, that's negative. And if we go and do 2 divided by 4, we're dividing by 4 here, putting a 4 on the bottom. That's not 2. 2 on top of 4 is a fraction that's going to reduce to be a half. Headed to this one, we'll want to get the x alone. There's negatives involved, so the question is turn or no turn. You could ask yourself that question for a second. And the answer comes back no turn on this, leave it as a less. The negative's not with the variable. If the negative was with the 2/3, then turn, but that's not what happened. When we divide by a fraction, we need to flip it. So over here, I'd have a 3 over 2. The 12 could be over 1 if it makes you feel better. When we multiply one of each, that's negative. Little cancel here, 2 cancels 12 to get 6. 6 times 3 is 18, and we want all of that. For this one, we want the x alone. The next question is turn or no turn, and in this case, ponder it for a second. The answer is turn, because the negative is with the variable. Negative and positive, one of each. When we do multiplying and dividing stuff, that's a negative result. The 3/5, to eliminate it, it's going to have to flip to be a 5/3. That's like it's over a 1, little cancel, makes it 10, multiplying away, grand total is 50. Small shift of gears, but same concept. Over here, these were all laid out on the board to be a multiplication setup, so you had to divide. These next few on the board are a divide setup, so you're going to have to multiply. But the same concept in terms of the turning of the sign applies. The negative has to be with the variable to turn the sign. So we want this x alone, and then ask yourself, turn or not. When we want this x alone, ask yourself, turn or not. When we do this one, when we get this x alone, the question is turn or not. Up here, we're not going to turn the sign. The negative's not with the variable. On this, we do turn the sign because the negative is with the variable. On this, we do turn the sign because the negative is with the variable. And if they're dividing, you're going to have to multiply. So if you multiply those numbers, it's negative 14, negative anytime there's one of each. This would be negative 24, again negative when there's one of each. This would be positive 35. The multiply and divide rules are positive anytime they're the same. Then we'll go up one more little step to a couple other ideas. Okay. On a question like this, we're not ready to right away do the lesson we just talked about to multiply or divide. We're going to have to combine like terms first. And there will probably be some in the homework where you might have to distribute first, or you might have to combine like terms first, or do some of those things first. On this, if we combine like terms, we get a negative 2x greater than an 11. Then we're ready to do what we've done on the board already 9 times. Okay. Get the x alone. The question is turn or no turn now based on how it looks now that we combine. It is a turn because the negative number is with the variable. When we divide different positive, negative types of numbers, negative and positive makes negative. 11 dividing 2, I'm just going to make a fraction. This one is ready to go right away. It's just decimals in it, so I saved that for a minute. Wanted to start with some nicer ones with whole numbers. When we get to x alone, the main question of the day is to turn or not. And in this case, yes. The negative is with the variable, so turn. And then we have to divide. 2 things you could do here. Well, first let's decide sign. Since it's a negative versus a positive, it'll be a negative number. If we're doing 0.7 divided by 0.4, the thing you're most familiar with would be to go 0.7 in, 0.4 out, and just go decimals. Move over, 1, 4, 3, drop a 0, decimal pop straight up, 7, it's 28, 2, fills another 0, 5. That's probably what you're most familiar with doing. What I might do myself is think 0.7 divide by 0.4 this way and do a decimal trick that I think we've done a little bit here and there. If we have fractions with decimals in them, if you move the top and bottom the same amount, you'd be fine. So we could go x less and in a quicker way end up with negative 7/4. We could have also realized we had that once we did this. In the box here, 4 and the 7, once we moved them over and you got 1 and 4 and 3, another choice would be there to go 1 3/4. Because the decimals died once we moved them over, even in that. We could have 1 3/4 still in that spot. This one, we're getting the x alone again. Turn or no turn, ask yourself that question. In this case, no turn, because even though there's a negative, it's not with the variable. When we go to divide, if one of each makes it negative for sure, and then 4 has to divide by 0.2. So if you like this way to divide, 4 with 0.2, move this over, so you move that over, 2 into 40 is 20. That's fine. If you want to do the thing we just did up here as a trick a second ago, 4 on top of 0.2, moves that over. So it moves that over, 40 over 2, it's still 20. It's 20 no matter what. This one, we have a variable on each side, so what we're going to have to do is eliminate one or the other of those. So if we go to get rid of this one, which makes more sense, because if we get rid of that one, we empty the side, and that's just a little bit awkward looking. If we get rid of a positive thing, we do that by subtracting 2x. That would make this 3x less than 6. Then it's like everything else we did today. We want the x alone. There's no chance of a term because there's no negatives anywhere to be seen. And now we're going to divide and get into. On this, if we get rid of this one so that we don't empty that side, we'd have to subtract 7x. Subtracting 7x would be a negative 4x less than a negative 14. When we get the x alone, this absolutely has to be a term. There's a negative on every single number, but the one with the x is the one that matters. Negative dividing negative is positive. We want to divide by 4. I'd go fraction style. 14 over 4 will reduce to 7 over 2. And that's what we're doing today. One main hazard, you don't want to get too carried away with the sign turning. Okay, it only is going to happen half the problems today, anything that's with the x. But if you get problems like yesterday's in the future, there's no chance of turning the sign if you're adding or subtracting. Adding or subtracting yesterday kept every sign faced the way that it was faced. Only multiplying and dividing is going to turn the sign the other way about half the time. Homework that builds off of this from 5.3 is on page 197. 197, we're going to work 1 to 30, and 37 and 38. So we'll do that for next time, and catch you then.